This conference will now be recorded.
So sort of starting from the top down, right? Our charter as a group, sort of from day zero, has been to do three things. One is some kind of an open data interface, which most of you are familiar with. Then reference designs, which is our POC group and the test work test package group, and then reference workflows, which is kind of the what CDX does and what the chiplet cost model does. And the idea is that we integrate all these and land on OCP modules with accelerators. And then we've had a picture which has sort of stayed with us. For the most part, it's actually been it's held, which sort of captures our stack. And the basic idea that drove the ODSA, and I believe that UCIe picked up on it, is that really, even if you have a die-to-die interface, whether it's PCIe, SerDes, BO, OpenHBI, AIB, or more recently UCIe, what you want to do is you want to preserve the system level protocols or the transaction protocols designers like. So for the most part, designers are in PCIe, CXL, AXI, or C6 was still active when we started. And originally, the original thing we spent a lot of time on was in the left half of this diagram. And so what we thought was, hey, what you needed to do was abstract away a die-to-die interface from the transaction protocol. So you needed some kind of an adapter. So you could carry regular transaction protocols on a die-to-die interface. And we said this should be true whether the die-to-die interface happens to be a bunch of wires on laminate or OpenHBI or AIB on interposers and bridges on advanced packaging. And so when we started out, we spent a lot of cycles, though we never published it. We have a lot of work on how to take off-the-shelf PCIe controllers, CXL controllers, or AXI, and map them to a BO interface. And the idea we came up with was we just borrowed one of Intel's concepts on a pipe interface, and later we thought we would do LPIF, but we ended up never doing it. Whoops, what did I do? Excuse me. Yes, okay. So what we ended up doing is we spent a lot of cycles on how to take an off-the-shelf. The portion of the diagram on the left says, how do I take an off-the-shelf PCIe controller? How do I take an off-the-shelf CXL controller? How do I take roughly an entire AXI stack and map it directly to a die-to-die interface? And so NXP gave us something called DiePort to map AXI transactions. And then we figured out how to map PCIe transactions to BO through a pipe interface. So we figured out a bunch of stuff, and CXL effectively would go through the same interface too. More recently, what we've done is make a lot of progress on the right-hand side of the picture. Just wait, what we really care about as a designer, what a designer really cares about is simply the transactions. Each of these blue boxes on the left comes with an entire stack on it. It comes with PCIe transactions, the PCI link layer, PCI file layer. And what we did was we simply removed the PCI file layer and replaced it with a BO file layer, or we took AXI, moved it from an internal bus to a BO or OpenHBI. And what we've made a lot of progress on recently is really clarifying our thoughts on how do you carry just the transactions, because that's what a designer cares about. The designer cares about just my transactions in AXI or my transactions in PCIe. A designer typically doesn't care about what's beneath it because that's more a protocol issue than a designer issue. And so what we've done recently between the BO group and the link layer group is really make a lot of progress in defining this. The one thing we've not done is continue with the standard interface. We said, okay, how do I take BO? How do I staple a link layer? And how do I carry common transactions on it? And this is the resulting diagram, right? And this really says, okay, if you're going to adapt or create an ODSA BO link, these are the parts of that link. That you're going to have a bow phi, then you're going to have a bow. Today it's a bow specific link layer, but eventually it can be moved out. We're going to have a bow specific, a link layer, which maps transactions onto the bow phi. And then on top of that, you're going to have what we're calling reference profiles, which really tell you how to map an internal bus onto the bow link layer. And finally, the third element we have, we just created more recently, called it out explicitly as a separate element, is we're creating an entity called a link controller. And this link controller, its job is to basically take the two elements on the data path and coordinate them with the far end of the bow link, coordinate their operation with the far end of the bow link. So what this portion does is really map onto this right half of our classical stack diagram, which kind of says, how do I have a bow? How do I have a link layer? And then how do I have transactions that map onto it? To be really precise, it maps, I can't turn this thing. It maps onto just this portion of the bow, and eventually I have to turn it to something like this. Ah, it's the map of the bow, the link layer, and the transaction layer. So we really haven't, the thing we haven't done is try to make these standard interfaces. We haven't made them an LPIF interface or defined a new standard interface. It's not clear that there's merit in doing so. And so we've stayed away from that. But we have a much more clarity in what this whole thing looks like. So I'll stop here with see if anybody has any questions, because to me this is a fairly significant development in what has in the work that the two groups have been doing. And Akash has been aware and active in both the bow and the link layer groups. Akash, I don't know if there's anything else you want to add on top of this.
Actually, I've been less active on the link layer, but I know that they're working on the link layer
Right.
to be able to define profiles and things like that for different standards. So I think that's ongoing. Yeah, my only concern is that we still have this attitude of being very, very open, and people can do anything, and then the competing standards very prescriptive.
Yes. Okay.
So I think that's maybe my big hot button is, there should be sort of predefined solutions for the vast majority of users, which kind of bolt on and work together, as opposed to just saying you can do everything you want, and then, but you lose some of that interoperability. So that's where sort of my hot button is, particularly if we're going to be doing known good die, etc. Well, known good die is useless if they don't connect to any other known good die, right? So.
Right, and actually we might have a fix for that. So you're bringing up, this was a discussion we had. One thing is, I think we made a huge emphasis on the spec being flexible in allowing a lot of options, but we're fairly narrow in specifying and tight in specifying interoperability. So if you want to be interoperable, there are a specific set of operating points you have to meet. And what we're going to do is, as soon as we finish the link controller specification, actually, I think you brought up a really important point. We are going to produce reference implementations, which may eventually become separate specs, which kind of say, look, if you're going to make an interoperable bow link, you use this bump map. And if you're going to use for this AXI bus, you use this profile and a link layer configured like so, and a bow file layer configured like so, and this is the sequence of controller messages you should use. So, Kash, I'm hoping that a very detailed reference implementation will address some of your concerns.
I think that should be our goal for sure.
Yeah.
Right?
Yeah.
So we should have something for AXI, for PCI Express,
yeah,
for Ethernet, all the common standards that real customers are using, and then we can keep them updated and so on. So I think that would be very helpful.
Yeah. So that's a very high priority that, we're going to look for volunteers for it. So we've got each of these three specs offer significant flexibility. We're going to narrow it down for a reference implementation. Any questions from anybody else? If we have a bunch of late joiners, I'm happy to go back to either of the two previous slides.
Hey, Bobby, can you show the first slide again, the mission of ODSA again?
For sure. So we've got three legs in our activity. One is we really want to make a marketplace happen in the end. I mean, we're not sitting here pretending that the marketplace is a thing that's going to happen in 22, but it's a wonderful framework to organize ourselves. And from that marketplace, we want designers to be able to assemble accelerators for common OCP form factors. And we think there are three legs to our activity. One is the interface. The second is reference designs and open designs so that the community can use it as a starting point for new activity. And the third is workflows. So best practices, models, spreadsheet models, information specs, CDXML, something that we just presented to the incubation committee as an example of a reference workflow. The test chip activity is an example of reference design activity.
Sounds good, thank you.
And what I'm presenting today is something that has been cooking slowly, is this right half. How to take the transaction protocol portion of stacks everybody knows and loves and map them through a link layer onto a bow interface. And we're also beginning to clarify what isn't present in this diagram, which is how do you actually control and bring up a link. That's this little box on the right. It's a link controller. And the link controller manages both the link layer and the bow file. Now, one important thing, the second thing we're sort of clarified our stance on is how do the two ends of a link communicate with one another? The most common option we think will happen is through a sideband. They need a sideband interface, and there are two options for sideband interfaces that we're enabling. One is we're assuming that the chiplet itself has a management interface. So we're assuming somehow that the link controller will communicate through the management interface. And if that isn't an option, we're saying we are also defining something called a bow sideband slice, which is literally a single bump slice. And the two ends can communicate their messages through the bow sideband. So in some sense, the bow sideband is really something that's associated with the link controller, even though we're calling it a bunch of wires. It's specified in the PHY.
Right. And this is the biggest area that I have my disagreement, because if you think about it, the other standard defines a sideband. It's always there. Everybody knows where it is. If you don't use it, it doesn't matter. What we say is, well, if you decide you want a sideband, you may put it on here, right? Or you could use some other mechanism. So from a known good die or building a big picture of chips connecting, known good die won't be able to even connect to each other or communicate or set up the links if one's doing one type of sideband, or we haven't defined a sideband that works within a slice, right? Like the other standards, right? What we've said is you could put it on the side, you could put it anywhere, you could put it within the die, you could not even have it. And what that does is then nothing will link with each other unless they have exactly the same sideband. So it depends on whether you think sideband signaling is important or not, right?
So
and for, I would say, for advanced protocols, it's very desirable for and for interop, right? So you just want that link to come up without, and designers shouldn't have to figure out, does my sideband, how does it anyway. So I think that this actually makes it somewhat useless from a big picture standpoint.
Right. So this is one of those weird things where I think we have strong convictions on both sides. The general conviction is anybody who builds a real chiplet is going to have a management interface on it. It's rare to see a chiplet without a management interface. And if that management interface exists anyway, why are we creating a separate sideband interface just to make the spec clear? And then I think there's a separate second issue, which I think is entirely defensible, that, why do we want a sideband per slice? What we really need is a sideband per link, which that I think is a defensible choice, Kash. It's simply for spec clarity, attaching a sideband interface to every slice is serious overhead.
I'm
But
not advocating for, what I'm advocating for is that there should be a way that is defined, and you can say it's across, multiple slices.
it's
What I'm saying,
mandatory is what you want.
I think that I know that that's an anathema to some people, right, to mandate something, right? But on the other hand, if you want two things to talk to each other, sometimes you have to mandate the language they speak. So, particularly at the startup, right? The sidebands are used to start up the link and negotiate the speeds and et cetera, et cetera, et cetera, right? So it runs at a lower speed. So anyway, I think this is more of a philosophical discussion, but it's also I think it's also a very practical one. So
it's fair, and it is. This is one of the things I think it's worth getting input from people who haven't been actively participating in the bovine link layers to see whether anybody else have an opinion on this. I mean, this might actually, the term raging hot might actually apply here. There's a pretty intense debate on whether we should mandate a sideband slice or not, or rely on the existence of a management interface in the chiplet. First of all, is the debate even clear? Sometimes we get so deep in the weeds that the specific debate sort of loses its, gets lost. Does anybody else have an opinion on whether we should, the two choices are, we should mandate the existence of a sideband component in the PHY so that the two PHYs operating PHYs can communicate with each other directly, or we should just rely on the existence of a link, sideband link, but that link may be outside the scope of the specification.
I personally also think the mandating would be better, just because I think if people look at the different options of various links such as UCAE or Bo, and they see like, oh, it's not clear what to use, and then I think a lot of them will ask like, well, how is this going to interoperate? And we don't have a good answer. And if we really just need like, say, 4 bumps extra or something, I think that would be hopefully something that most people could follow. So that's my personal opinion.
Okay.
Hey, Bobby.
Yes,
so
sir.
I've seen some designers and customers, they want to control both ends of it. That's to say, they have they design 2 chiplets or multiple chiplets, and they want, it's not like they are interfacing with a known chiplet, but they are interfacing with their own chiplets.
Okay.
So they want to have control. So we need to have an option for those class of customers or users. Instead of mandating, we should have an option for them to do what they need to do using a PHY, right, or using PHYs as interface or BOW as interface.
Yeah, so
right, Tony, but
yeah.
that's really for a closed system, right? And I completely understand. So for a closed system, you do whatever you want, and it doesn't even really need to be Bo compliant. I mean, we can use the Bo standard or whatever, right? So you can customize and do whatever you want. The question is,
no. So let me explain. Maybe I
yeah,
wasn't making it clear. So this is not so much on a closed system. Like, for example, some customer might be sourcing suppliers, right? Different suppliers. For example, just take three suppliers as an example. So I'm in foundry. So when I say supplier, meaning the foundry supplier. So like say Samsung is one, Global Foundries, and TSMC. Just using it as an example. So they will be designing the chips with each of the suppliers, right? And then they're gonna build a system. So the supplier, the BOW might not come from the same provider, and the customer would not be designing their own interface, right? Or their own die-to-die PHY. They're just relying on a third party or whatever, right? So in that scenario, customer would still wants to control how they're using, customers will be using those hard files, but they want to make sure that they control all the interaction between all the three chiplets with different suppliers. So I don't consider that as a closed system. To make things more complicated, the supplier of or the provider of the files might be coming from different companies.
I think Tony brings up a good point, like about the maybe I see it like slightly less like this idea of having that some people want to like design both ends of a chiplet system. But I guess going towards Kash's point, I think it would be nice to have a recommendation if you want to design for interoperability. If you think of like you want to build a chiplet for a market system or for a market like in the future, that we have clear recommendations there. And if you want to be designing your own system with a subgroup of partners or just for yourself, then of course you can like decide, like we can see all these things more flexibly.
Yeah, I think that's very logical, right? So it answers both questions, I think.
Yeah. So
but clearly.
Yeah, what I'm advocating for is we want to have options, right? If you don't want to, if you just say relying on what ODSA provides as a standard, here's the set of protocols you need to follow. And if you want to design your own system, okay, you're free to do it. Still leveraging BOW as an example.
Right, but Tony, yes, you're getting your silicon from 5 foundries, let's say, right? But let's say you're AMD and you're using your foundries, you're building your overall system. It's still a closed system from, you're not opening it up to have other chiplet providers, right? So that they can just buy and then build an. So I think that there is a philosophical difference, but I do agree that certainly customers need to, there will be one advantage of Bo to be able to say, look, this is your, known good die kind of independent kind of path, and here's a more optimal where you kind of have the flexibility to do whatever you want, but within your system requirements, right? So I think that makes a lot of sense to have both, but it needs to be clear, not hey, just say, hey, you can do anything you want. I think that's the
right.
How much of that is wordsmithing that we just are not, like if you look at the actual interoperation points, they're very precisely defined in Bo, but they're not that flexible. It's just the spec says, hey, we're very flexible, but the actual interoperation points are rather tightly spec'd.
Except the sideband.
Except the sideband, right? But
right.
I mean, what I'm saying is some of this may just be like, our wordsmithing. What I'm hearing Marek say, and I think I'm hearing Tony say that, is that you want to get to a point where you say, look, if you want an interoperable interface, use a sideband. Otherwise, if you want to guarantee interoperability, use a sideband is what I'm hearing. But not mandated as such.
Right, and a proposed bump map for that or whatever. So
And a
I
proposed
think
bump
that's,
map.
Yeah, I think
But
that's
it's slower,
what
right?
I'm
So
saying.
bump
And
map
I
may not
could,
matter as much.
And it could be even be like the sideband is like one option, just to say like one thing that people are supposed to use. It doesn't matter what it is. If the sideband is what we want people to do, I just like think it would be good if somebody says they want a chiplet and they want to know that it is going to interoperate with something that comes out in like 2 years later, then we just have to have some kind of like basically best practice on how to design it.
Okay, so a chip will have to have as many sideband interfaces as the number of distinct links it supports. I mean, as an example. Okay. Anybody else want to chime in? I'm asking, not complaining. Alan, Nick, you guys are logic layer guys. Tony, please continue.
Just like the idea.
Yeah, my only feedback here is that the sideband, if it's every 5 slice becomes an overhead that gets accumulated. So you got to see what the cost benefit is of replicating it on a per 5 slice, or whether you.
No, but that's off the table. That we know is off the table. It's more like, do we mandate it per link or do we not mandate it per link? Is the sort of raging debate right now. It's an optional thing.
Yeah, my experience is that having something there to get both sides synchronized and aligned is necessary, because what's going to happen is going to have very different. Everybody's going to do it differently, and it's not going to be common, right? So one person will use I2C, and I may use some other signaling. You got to standardize it so that it's consistent, especially if you're doing a chiplet marketplace. You don't want to have different implementations in there, because then.
Yeah, I agree with that. In fact, in the DCSCM efforts, Lattice have proposed LS PC, basically an LVDS link that puts all of the sidebands onto one LVDS pair. It's been used to minimize PCB congestion with many I2C buses, but I think there's an opportunity to integrate that, and that's part of an OCP effort. I think Libra BMC effort, etc. So that could consolidate sidebands down to just a single differential pair, and then, like you say, whether you do it as a per link or you just aggregate them together if there's multiple links, would make sense.
Okay. Anybody else with any opinions? Because this discussion so far has been really useful. Okay. In that case, I think for the most part I'm done. I'm happy to go through the rest of the slides. I put them in more to, if this is my take. I mean, we have to synchronize on this, but roughly our take on how this happens is that basically the TX sort of waits for the RX to tell it it's ready. The RX, so basically action is initiated by the TX, but really it's led. The state changes are led by the RX side of the interface. And I drew these about 3 weeks ago. So so essentially what the generic vision is, or generic thought process is that what's going to happen is that you're sort of going to go into use an idle. As soon as the interface comes up, you're going to sort of use the idle an idle pattern to sync the two sides, and this is a per slice bring up. And then you're going to go into a sequence of patterns where you send tests of various kinds: tests for an individual slice for repair, tests for an individual, for a link as a whole, which is multiple slices. And each test is essentially a sequence of, I start with an idle, run a test. When the test is when the test is complete, then you send an idle again to sort of indicate that, okay, I'm ready to. You say I'm ready to for an idle. So it's like idle test, a sequence until all the tests are done. And when all the tests are done on the adequately registered on the transmit side, the link is brought up. And in this sort of abstraction, so where you basically go through a test sequence over and over again in a decent loop until you get to link ready. So here you see these two test states, and you just go through them over and over again, and finally you bring the link up. And I've defined a set of messages which eventually all of this will go into between what Elad has and what these are will go into the link controller spec. But the rough outline of the link controller is the TX wakes up, but then it waits for the RX to sort of lead it along from state to state. And each end of the link is brought up independently, and there is a link controller which sort of confirms that both sides are up. That's the rough process for the link controller. That's basically it. I mean, I'm happy to walk you through the weeds, but unless you guys are really interested, you have to really want to care about the link controller for these messages to matter for you. But this one I think is important to the group as a whole. And that's what I have. I'll just do unless there are any other questions, I'll do a quick round of. Tony, go ahead.
Are you sharing these slides in the website or?
Not yet, because we're
Okay.
going to change them. They're still sort of work in progress, and if I change them, then we'll have these old versions floating around.
Okay.
Probably within the next couple of weeks or so is my guess.
Oh, okay. So it's work in progress. Okay.
Yeah.
Got it.
I
Thanks.
want to nail down like a flow for the link controller. This slide is almost complete. We're sort of working on really the intent of this is excuse me, let me organize my thoughts. There's going to be a second slide which kind of says these are the specs you need to put a link together. You need a bow spec, you need a link spec, you need a reference profile, you need a link controller spec. And on top of that, we're also going to put together at some point, that's not going to happen in a couple of weeks, but that's high on our wish list, is this reference implementation that Kash and I were discussing. And so Michael, Swami, any opens, any questions?
No, thanks.
Not from me, thank you.
Kash, Alan? Alan Chan. Oh, Alan Cantle, thank you.
No, not for me.
Okay. Tony, Marek, any other opens?
Nope.
Ivo, Nick?
Hey.
Tony, go ahead, please.
Oh, sorry. A
No,
little
go ahead,
bit
please.
slow. So a while back, we discussed getting some collaboration with UCIE
Right.
in terms of at least trying to understand what are the points of collaboration. Has this activities been started? Any updates on that?
No meaningful updates. I think the amount of sort of informal contact with them has increased with the UCIE effort, but and there are several people who are active in UCIE who are active in different work streams. But sort of with official UCIE leadership, I don't think we've had any real contact yet. I think we're going to get there. If I had to bear, they're settling down. They've got a board of directors and everything else, and my guess is we'll do something over the next 2 quarters. Is my guess. Something will happen with either in this Q4 or early mid Q1.
Okay, good to know. Thank you.
Bapi, actually, this week's UCIE meeting, DJ was present there, and he had a few discussions. So, from what I see, that there are some interactions happening.
Yep. Thank you. Ivo, Nick, or Ivo, I'm sorry.
Thank you, Bapi.
And
No, I don't have anything. I'm still listening.
okay, I'm not able to see that. I see it's Yin, and who's the other? And Mike. Yin and Mike. Anything on your mind?
No, from my side. Thank you.
Okay. Then in that case, next week we're going to have a pretty good talk. I think I've set up John at Cadence for next week. It's a talk he gave at EPEPS about the different kinds of packaging and what they see as the workflow for packaging that is probably worth your time. So I will see you next week. See you all next week. Have a good weekend and everything.
Thanks, Bapi.
Hey, thank you. Have a good week.
Thanks.
Bye-bye.
Thank you.
Thanks. Bye.